Structural analysis 2, chapter 8, deflections using energy method. Last time we solved this frame with the help of virtual work method in terms of integration. Today we want to solve this problem the again virtual work method, but like avoiding integration, but just by graphical method, which is far simpler. Let's attempt our problem. So again, we want to calculate delta C horizontal. How far support C travel to the right? So again, if we have the real member, I want to get the first the reaction, so converting the distributed load to concentrated at the center, then summation of moment about A gives us Cy is equal to 25 kilopound. If you want to review this problem, we had solved the problem with the virtual work integration condition in previous video, which I will provide you with the link to that video. But this time we want to solve it with virtual work method, but just graphical, which is an easier approach. So if Cy is positive 25, Ay should be negative 25, and if the total force is 40 over here for the real forces, Ax is a outward 40 kilonewton. It is same applying a 1 kilonewton at this ball C, at the support C, and then summation of moment about A gives us a C by 1.25 upward, A by 1.5 downward, and if this is 1K, that should be cancelled out by AX over here. Then as soon as we have all of them, so for example, if this is the virtual one, there is no moment here, no moment here, definitely B is fixed, there is a moment there, and if this is 1.25, it just gives us 1.25 times 8, it just gives us 10, 10, and if you just connect the dot, that's the graphical format of virtual moment. And if you want to do the same for the real moment, so again, if this is 25 times 8, it's like 50 times 4, that's 200. This is the same with this one, and this is 0, and we get a parabola shape. So then by having a numeric value like the same, like 10 kilopound feet, 10 kilopound feet at all sides, because the moment here doesn't change, so these two numbers remain the same, these two numbers remain the same. This is the virtual moment, this is the real moment. Now, instead of integration, we just multiply the area. So graphical method says if you want to evaluate the integration m small m capital M, just assume m is equal to m prime is capital M. So if you have, for example, a rectangle times a rectangle, we have 1/3 small m capital M times L. And now our case is in a whole set of different cases. So our case, like for horizontal members, like a two triangles multiply by each other. So that gives us a 1/3 m times m prime times L, or small m capital M times L. So, and for this vertical component, one of them is something like a triangle, the other one is parabola over here. So that's 5, 12. These are the two equations we do need for graphical method. So m integration of m times small m capital M dx is equal to a third of m, a third of 10 times 200 times length, which is 8 plus 5 over 12, which just comes from here, small m small m capital M small m capital M times the length, which is 10 feet. If you add them up together, it just gives you 13,666.7 kilopound. And if you divide it by EI and do the math, it just gives you the same numeric value like previous problem. Thank you.